Welcome to Math 2318, section 4.6. In this section, we're looking at some more calculations on rank, null space, column space, and row space. All right, in question 1 here, question 1, we have matrix A. They tell us matrix A is row equivalent to matrix B. A is 3 by 4. Therefore, it's going from R4 to R3. Well, let's see. If it is row equivalent, then looking at B, I see that there are 2 pivot elements. Therefore, the rank of matrix A is 2. All right, well, what about the dimension of the column space? Well, the dimension of the column space, remember, is the following. We've got rank of matrix A plus the dimension of the null space of A, and that has to be n, and here n is 4. So if the rank is 2, then the dimension of the null space must be 2. What about a basis for the column space? Well, since there are 2 pivot elements and they are in column 1 and 2, then the basis is just what's in original matrix A, column 1 and column 2. What about the rows? A basis for the row space? Well, similarly, I come here to matrix B and I get the 2 rows that had the pivot elements in it. Well, let's see, what about the null space? What can we say about the null space? Well, if you look at matrix B, then an element in the null space has to have this particular format, because if you just solve that x3 and x4 are free variables and what x1 and x2 need to be, and now split off the x3 part, split off the x4 part, I get my 2 basis vectors for the null space of matrix A. Alright, well, let's see. They give us some more information here. Suppose A is 6 by 9. Alright, if A is 6 by 9, then A is going from R4 into R6. We know it has a rank of 4. Alright, so if the rank is 4, and I know the rank of 4 plus the dimension of the null space has to be the number of columns. Alright, well, the rank is 4, and so I get 9 minus 4 is 5 for the dimension of the null space of A. Well, we do know that the rank of a transform is exactly the same as the rank of A, and so it has to be exactly the same, which is 4. And the dimension of the row space is 4. All right, let's see. Question 3. Suppose A, which is 6 by 9, and again that means it's going from R9 into R6. What's the dimension of the null space, and is the column space R4? Well, let's see. We know it has 4 pivot columns, so the dimension of the column space is 4. That is the rank of A. So if the rank of A is 4, the dimension of the null space must be 5 because we have 9 columns. Well, let's see. If the dimension of the column space is 4, that certainly is not the case then that the column space is R4 because we're going into R6 and the column space is a subspace of R6. Let's see, question 4. We want to look at U times V transpose. Well, what is that? Well, here's U, here's V transpose. I have a 3 by 1 multiplying a 1 by 3, so the answer is 3 by 3. And so we're going from R3 into R3. Well, if you look at it, it's just ABC in each of the terms multiplied by minus 3, 7, and 2. Well, divide the first row by minus 3, divide the second row by 7, and the last row by 2, and you see all the rows are the same. And so I can make two of the rows 0 by doing row operations, giving me a matrix that looks like the following. So there's only one pivot element, so the dimension of the column space is 1. Alright, so the dimension of the column space is 1, which is the rank. I know that I have to have 1 plus something be equal to 3. Number of columns was 3. So the dimension of the null space is 2. So how can I get something of a rank less than 1? Well, if it's less than 1, then it has to be dimension 0, which means my matrix would have to have A, B, C, all three of them be equal to 0, because then I get that the only thing in the null space is 0 itself. Alright, so let's see. In this case, in question 5, I want to find a V where U times V transpose is this matrix. Alright, so let's see if I want to make this multiplication make sense. I've got a 2 by 1, multiply it by a 1 by 3. So my unknowns are A, B, and C. So it has to be of this format. Well, matching that up with what we need it to be, you can see A is 1, B is minus 2, and C is minus 3, giving my vector V in R3 of this particular format.